How's it going, everyone, and welcome back to another video. In this video I'm going to be discussing this thermostat housing that failed in a BMW 5 Series. I replaced this component, and because it is a different type of thermostat housing, this is a map controlled thermostat housing that's in this type. I want to give you some information on why map controlled thermostats are put into vehicles, how they can fail, and how they actually work. So without further ado, let's get into it. So this housing assembly is part number TM1497. The 97 stands for the degrees that the coolant needs to be to open the thermostat on these. They come out in 3 Series and 5 Series BMWs, and I will link in the description all the info I know of the models that this exact unit goes into. So why would a manufacturer make an electronically controlled thermostat? Why would they design it? Why would they put it in? It just seems like another reason that an item is going to fail unnecessarily. Well, the main benefit of this type is to be able to open the thermostat before the coolant actually reaches the operating temperature for the thermostat to open. So you have better control of the engine temperatures, and that becomes very useful when you are under certain conditions like climbing steep terrain. The coolant isn't hot enough to open the thermostat, but the ECU can command that it opens by sending 12 volts down here even when the conditions of the coolant temp isn't met, and it will open up the thermostat and allowing for full flow afterwards. So this map control thermostat has an inbuilt heating unit that, by commanding the ECU to turn on, can open up the valve when it's required to. The ECU is able to adjust the amount that it opens up, so adjust the amount of flow that the coolant has based on required conditions. What is that useful for? It's useful for reducing the emissions. So you'll find this in petrol engines, and to help with emissions, the likes of HC, the hydrocarbons and CO2 emissions, it lowers those. It also helps reduce fuel consumption, and it has a more complete combustion event by doing that. What is engine map? Engine map is the way the ECU controls the engine and thermostat. That is not a map as in manifold absolute pressure. It's a map from the ECU, which is how it controls this unit. Now, error codes that can be connected with the likes of this and other model vehicles, again I will link in the description, but some of the common ones are P0597 in the likes of the GM group, P0116 in the VAG group, and 2EF7 in the BMW group. They are common fault codes for the likes of these housing assembly failures. Alright, so let's open up this unit and talk about the functionality and how it actually fails. So these are T30 Torx heads that are holding this assembly down, which I'm going to open now in a second. But just before I open this all up, there is some ways that you can visually check these items before removing completely. The likes of these assemblies can be difficult to take out in some cases, and depending on which model, make or model that it's in, you may be able to get visibility to see a actual failure inside it. So one tip is removing one of the hoses from that's going to the radiator, looking in directly and seeing if there is clips or broken damage inside the housing assembly. If you have that, well, then the thermostat isn't sitting in its position and it's not able to open and close like it should. That is one failure that is showing up on it. Another one you can do is you can send voltage directly down to it, and you can look in by taking off a hose to see if it's opening and closing. If it's not, you know you have a failure on that side as well. One other thing is the actual unit, the heating element unit on this, a lot of techs mistake that for the temperature sensor in the thermostat. They think that that's actually the temperature sensor, whereas it's actually the heating element on it. So make sure you don't get confused. There is housing assemblies that has both. I think Volkswagen and the GM ones have the temperature sensor on one side, and then you have the heating element. So that is the top section off. There is your thermostat, and if you look here at the base side of this is where the heating element is going to happen here. So I'm going to try and separate this unit and move this back out of the way. And if you can see there, you can see the heating element goes directly down into it, which will cause the thermostat to open and close. So this unit here has completely failed, so even when I apply voltage directly there, this does not open. It stays closed at all times. I'm just going to hook up the power here and show you exactly what I mean. And as you can see there, I have voltage applied, but this is not capable of doing anything. This isn't capable of moving, it's not capable of opening, and this unit has failed. So the heating element may be gone in the unit, but let's check out the thermostat itself. Get you a bit of visibility. Pop it like that. I don't know if you can see that too well on camera, but that is staying completely closed. It's not opening at all. I don't know if you could see that fully, but the thermostat did not open at all at any stage. Just up in this section here, that should lift off its seat and allow coolant to flow through. It's stuck in the closed position at all times. Heating element is not working here to open it up, and nor is the temperature. So we put boiling hot water, it's 100 degrees, and it still didn't open this thermostat when required. So that is it, guys. That is how the map control thermostats actually work. The reasons for them to fail is they can be stuck open, they can be stuck closed. The actual housing assembly itself that it sits on, it can have clips that the thermostat retains in position. and they can break away and cause the unit not to be held down right. That can also happen and cause failures. In this case, you can apply voltage and it is stuck closed. It does not want to open at all, and that's why this unit needed to be replaced. A quick recap of why these are beneficial compared to your regular type thermostats. Like we said, ECU has complete control of it. It's able to open it before it even gets hot enough to open based on the coolant temperatures. You're going to lower the emissions, and that's the main reason these were brought out. By lowering those HC and CO2 emissions, you can reduce fuel consumption, and that is a big benefit in these emission-driven vehicles. The emissions being so strict in modern vehicles, they had to come up with smart solutions, and this is just another one of those that they introduced. I hope you enjoyed this video. I hope you found it informative, useful, and if you didn't know about these type of thermostats, make sure you give it a big thumbs up. Subscribe to the channel if you haven't, and I hope to see you in the next one. Thanks for watching.